Okay, I'm just going to wait for this to make sure it actually starts recording. All right. So right now, my terminal, or the shell, is running in this directory called, oh, sorry. It just pasted into the terminal by itself. Okay, so it's running in this directory right here, right? And you can see that this is like the 8th directory deep relative to root, right? So there's root, and then home, Burton, blah, 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 all the way down to here, right? It's not unusual for your directory structures to be very deep. Now, if you're here and you would like to go somewhere else, right, you can always, if you happen to know the absolute path name of the directory you want to go to, you can always type in the absolute path name, right? Now, a lot of the time what you want to do is you want to do something like, I want to go back to my home directory, right? And so in bash, to change to your home directory from anywhere, you can just type cd on its own. Press enter, right? And that takes you to your home directory, right? So cd on its own switches to the home directory. You can also get to your home directory by typing in, so let me go somewhere else now, 2023. Whoop, whoop. So I'm going to go back to where I was. Sorry. Come on. There we go. So I'm back to where I was. Let me clear that. Right, so I'm in this directory again. You can also get to your home directory by typing in cd and then space and then tilde. Tilde is the, it's normally in the upper left-hand corner of your keyboard. It's that symbol there, right? So tilde is what's called, it's called a tilde expansion in bash. Right? And so you're going to see a lot of these expansions, right? So as over the next week or two, I'm going to be talking about expansions and substitutions all the time, right? This is one of the expansions or substitutions in bash. The tilde expansion expands to the home directory. So it expands to the home directory name. Now when I say expands to the home directory name, right, what that literally means is when you type in the tilde character, when your shell looks at that, sees that character, it replaces that character with the name of your home directory. Right? And so if I type in cd tilde, right, before the shell interprets that, while the shell is interpreting what I typed in, right, it replaces the tilde with root home / Burton for me, right? And so that will also switch you to your home directory, right? Now it turns out you can, or the user can change what tilde means for them. So you could replace tilde with, instead of your home directory, something else, right? I'm not going to tell you how to do that. If you want to know how to do it, you can look it up. It's pretty straightforward, right? But by default, tilde expands to the name of your home directory. Right? Okay, so the current directory, it has the name dot, right? So if you type in cd dot, that does nothing, right? It goes to the current directory, right? So dot is the name of the current directory, wherever the current directory happens to be, right? So for example, if I switch into, let's do 2023F, right? Again, dot is now the name of the current directory, so that's 2023F. Right. The parent directory is dot dot. So cd dot dot, right, goes up one directory, and I'm now back in my home directory, right? And you can use these names as part of a sequence of directories to move to. Right? So let me go back to this very long, this directory where I started from. Right, so again, sorry, I'm here, right? So if I want to, I can do cd up up / up up, right? So go to the parent, and then go to the parent of the parent, right? So that should take me, so that's the parent directory. So that should take me into the bash directory, right? And indeed, that's where I am, right? If I want to, I can write cd dot / right, scripts something else. So permissions, right? And now I've moved from the bash directory to the scripts directory to the permissions directory, right? So the dot there, right? Current directory, right? The scripts directory in the current directory, the permission directory in the scripts directory, right? And you can combine all of this stuff together, right? So I can go do something like cd up, 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 up. So that takes me scripts, bash, one more, right? So now I'm in sys220 current main, right? Then I can do dot if I want to, which doesn't do anything, right? And then I can go to the C directory, right? And now I'm in the directory containing all of the C notebooks, right? So you can chain all of this stuff together, right? You just follow the sequence of directory names, right? So go to the parent directory, parent directory, parent directory, current directory, the C directory, right? And of course, if you want to, you can use the actual names of the directories if you happen to know what they are, right? And that basically closes out that the file name the file system notebook. All right, so for today, we've got a set of lecture slides. But again, you can just read the command notebook as well. All of this stuff is in the command notebook. Okay, so the bash command structure. So commands in bash, they all behave more or less. They all have the way you use them is similar, right? So bash commands can be one of four things. They can be these things called a built-in command, right? So we saw in the previous lecture, some of the commands like cd and pwd, the shell understands those commands or is able to execute those commands by itself, right? So in other words, they're built into the shell. Many of the commands that you'll use, they're just programs, right? And so we saw, for example, ls is just a program that exists somewhere on your computer, right? When you type in ls, it runs the ls program and something happens, right? You can write these programs in whatever language you want. Right? And so a lot of the programs that you use, they're actually compiled programs, probably written in C, right? But if you wanted to, you could write them in Java or in Python or whatever else you want, right? And as long as they are runnable on your particular computer, you can treat those as though they were a command, right? So they can be both compiled or scripted, right? You can have these things called aliases. So aliases are just different names for existing commands. Right? And so you can create shortcuts for yourself. So if there's a command that you use all the time that has particular options that you want to use all the time, you can create yourself a little name for that command and options. And then you can just use the alias instead of the command. And then finally, if you write a function in your shell programming language, right? So just like you'd write a function in Python or a method in Java, you can actually call that function and use that function as though it were a command, right? So we can later, well, I guess like 5 weeks from now, when you learn about bash functions, if you put that bash function in a file somewhere, you can actually call that function as though it were a command, as long as the shell knows where to look for that file. If you want to know what type of command the command that you want to use actually is, it's not often that you want to know this, but in case you do, you can use the type command to find out, right? So if you go to your terminal, and if you go to your terminal, right, and type in something like type ls, oh, this one actually says it's an alias, right? So there's an example of an alias, right? So when I type in ls on my computer, it's actually this command that runs, right? So ls ---- color equals auto, which when it prints stuff on the screen, it prints it in colors corresponding to whatever information the shell happens to know about the file, right? If we do type cd, right, that tells you that it's a shell built-in command, right? Remember, if you want help on a built-in command, you use help, right? Or you can use help. If you have an internet connection, Google's usually faster, right? Is there another one? What's the other one? So we have ls, cd, la. Oh, la is another alias. So type la. Oh, yes. la is aliased to ls minus a. I think later in the class I'll show you what ls minus a does. Right, so the type command gives you information about the kind of command, the type of the command. Right? Which command tells you where is the command on your file system if it's an executable program. Right? So if I want to know where does ls exist on my file system, type which ls, right? And it tells you it's in root user bin, it's in root user bin, right? And the program name is ls, right? If you type in something like which cd, now remember cd is a built-in command, so it prints nothing, right? There is no program corresponding to cd, right? cd is a command that the shell understands by itself. Okay, so ls we've seen already, right? So I've shown you ls. It lists information about the current directory by default, right? But more generally, it lists information about files, right? So if I were to switch into the bin directory and type ls, right, that simply lists the file ls corresponding to the ls command, right? Now that's not super informative, right? So if you type in ls in the name of a file name, that's not super interesting, right? Which directory I'm in. Okay, so if I type in ls, I can see there's a whole bunch of files in this directory, right? Let's pick one of them. So ls compiling, right? Okay, so that says yes, the file compiling IPYNB does in fact exist. Not super interesting, right? Normally, if you're asking about information about a file, or if you're listing a file, you want to know something about it, right? And so, if you want to know how big a program is or how big a file is, that's what minus s does. Oops, sorry. Right. I'm just going to use slightly different examples here, right? So ls minus s compiling.ipy. Oops, there we go. Right, and so that prints a little 8 beside it, right? And that says, and then the name of the file, right? So the 8 is the size of the file, right? What units is it in? It's in some funny unit called a block, right? If you want to know how big is it in something more sensible, right, you can use ls minus sh, right? So h means human readable, right? And that tells you it's 8.0K, which just means it's 8 kilobytes, right? Not particularly big. It's just plain text, right? Right? So that tells you the size of the file in human readable format, right? So by default, if you type in ls minus s, you get the size in units called blocks, right? To get the size in something that makes sense to a person, you want to use, you can use the h option as well, right? And so what I've just shown you there is how to use one or more options with a command, right? And so when you use a command in Unix, it's the name of the command, right? If you need to, or if you want to, you can pass in 0 or more options, right? The options always start with either a single hyphen or 2 hyphens, right? So single hyphen and then the name of the option, right? Some options will have arguments that you have to pass to the option, right? And then you can pass additional arguments to the command itself, right? So when I used ls, back here, right? So here, that's the command name. Here, I'm using 2 different options, s and h, right? And that's an argument to the ls command, right? So list the file compiling.ipynb telling me the size in human readable units, right? And you can combine options, right? So if you want to, so this one actually uses 4 options, a, s, h, and 1, right? So you can write it out like that. So let's write that out, ls minus a, s, h, 1. A, s, h, 1, right? Okay. So let's take a look at the output there. Sorry, let me clear this and redo that because it's easier to read. There we go. All right, so now you see, so S we know what it means and H we know what it means, right? It prints out the size of the file in human readable format, right? 1 means output the information in a single column, right? So 1 file per line, right? That's not exactly true, but for our purposes it's true, right? So 1 file per line. Right, so we see that that file there is 28 kilobytes, right? Untitled.ipynb is 4 kilobytes, right? And so on and so on and so forth, right? Now, what does the A do, right? So one column output, S size, H human readable format. Now what does that A do? So let's get rid of the A and see what happens. Notice I've got stuff in blue, so notice there's that file right there, right? .ipynb underscore checkpoints. Okay. So I'm going to do the exact same thing, this time not using the A. Boop. Right. Boop. Okay, notice that that file that appeared before, right, does not appear here. Right? So the A, the capital A, means almost everything. Right? And by that, I mean it prints out any hidden files that are also in the directory. Right? And so in Unix, if a file name starts with a period, it's considered to be a hidden file. Right? Commands like ls will not list information about hidden files. Right? If you, later on when I show you pattern matching, so how to specify groups of files, pattern matching does not by default match any of the hidden files. Right? The hidden files are typically files or directories that contain some sort of configuration information for a program. Right? And so .ipynb_checkpoints, that's what Jupyter Notebook stores information in that directory. Yes, in that directory containing the state of each Jupyter Notebook. Right? So that's information that only Jupyter cares about, so it decides to put it in a hidden file in this directory. Right? So anything that's hidden, not normally listed by default. If you want to see the hidden files, right, it's -a or big A, little a or big A. Right? Oh, I guess I should tell you something else. So for Mac users, you can use the commands, like you can use ls to list the contents of a directory, right? But you can also use your Finder, right, to easily list the contents of your directory. On Windows, if you really want a graphical interface to your file system, right, you can also get it in Windows, right? So in Windows, if you want to open up Windows Explorer in a particular directory, right, you just type in explorer.exe and then dot, right, dot for this directory, right, press enter, and that fires up your Windows File Explorer, right, and that lets you look at your Linux file system in the Windows File Explorer, right. So I can go up, boop, 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 keep on going, sorry. Okay, so I can go all the way up to the root directory. So the root directory is going to be called Ubuntu, or if you install Debian, or whatever else, right, it's going to be called that on Windows. Right? But now you can drag and drop files and things like that using Windows Explorer as well. This is useful when you go to do your assignments because you probably download your assignment in Windows, right? And then you want to drag it over to Linux, right? And so to do that, explorer.exe space dot in Linux, and that will open up Explorer, and then just open up another Explorer window and copy your files over. Again, in Mac, just use Finder. Okay, you can also, if you want to, you can specify all the options individually, right? So that is exactly the same as that, right? It doesn't matter how you do it. They're both the same. They both end up producing the same result. Now, there's also what are called long form options, right? So that exact same command, I can type in that way. You cannot combine the long form options into a single option, right? So I can use -- almost all, -- human readable, -- size -1. Right? And so if you're typing it in directly from the keyboard, you're probably not using the long options, right? That takes too much time to write. One of the reasons the long options exist is because you can put these commands into a program, right? So when you write a bash program, you're just writing a sequence of bash commands, right? And so if you're writing a program, right, it might be useful to use the long options instead so that when you read your program, it's a lot easier to understand what are all these options that you're passing into this command, right? This is a little bit easier to understand compared to -AHS1, right? Unless you happen to remember what ASH1 means, right? So the long options do exist. Okay, so there are a bunch of commonly used options for ls, right? -big A, right, is almost all, right? So that lists, so little a lists all the files, even the hidden files, right? Big A lists all of the files, even the hidden files, but it never lists dot or dot dot. So what the heck does that mean, right? So back here, if I type in ls, I get that, right? If I type in ls -big A, right, I now see the hidden file that's there, right? And if I type in ls minus little a, right, I see the hidden file, right? But it also always prints the other two hidden files, right? Dot starts with a dot, so it's a hidden file, right? That's the name of the current directory, right? Dot dot starts with a dot, so it also lists that directory as well, right? Remember, that's the parent directory, that's the current directory, right? Because they begin with a dot, they're considered hidden files. If you want to see them for some reason, use little a. You never want to see them, use big A. Okay, so there's a whole bunch of options. Don't memorize what all the options do, right? Well, except for possibly A, right? So some of the more common ones like A and 1 and L later on, I'll show you what that does, right? You might want to commit those to memory, but otherwise don't bother memorizing them, right? If you need to use them frequently, you'll end up memorizing them, right? If you don't need to use them frequently, you can always look up how to use them. Right. Minus D will list the directory name instead of the contents of the directory. Right. So here, anything in blue is a directory. So there's a directory called images. There's a directory called source. Right. If you type in ls source, sorry, let me clear it again. Right. So if I type in ls src, right. So src is the name of a directory. Right. So what ls does is it lists the contents of the directory. Right? So it prints out, hey, there's a whole bunch of directories in that directory. Right? If for some reason you only want the name of the directory, right, so I would only like to see src, right? That's what the D option is for. Right? Instead of listing the contents of the directory, right, it lists the name of the directory. Right? And you might want to ask, well, why on earth would you want to do that? Right? And so one of the reasons I might want to do that is because if I do something like this, right? So LSS star, right? So that's an example of a pattern, a pattern in Bash, right? So star means match any string, right? So this says list every, the arguments to ls are everything that starts with an S in this directory. So S star means match every file name starting with S, right? So that's src, statement, string, blah, 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 right? One of these files is a directory, right? And so what this thing here actually expands to, this is another expansion. This is a wildcard expansion. There's a, where to go? Sorry, I'm looking for the other brush. Oh, anyway. So in this particular example, LSS star expands to ls, right? src. Oh, wait, sorry, no, that's not true. Scope. Right? So you start listing out all of the files that begin with S. And so on, right? And so when the shell sees that, it replaces that with all of this, right? And then it runs the ls command, right? So ls processes each one of these arguments in turn, right? That's a file, so it just lists the file name. That's a directory, so it lists the contents of the directory, right? That's a file name, so it lists the file name. Right? It then reorders the output, right? And so you see there are all your files listed, right? And there's src listed, but when it lists src, it also lists the contents of that directory, right? When you're writing a script to do something programmatically, right, you may not want to know what files are in the directory. All you care about is that a directory exists, right? And so that's when the D is useful, right? So when you use the D option, right, that suppresses, or instead of listing the contents of any directory, it only lists the name of the directory itself. Right, so there's what D does. Right, minus F appends an additional character to indicate what type of file it is, but then you need to know what the character means. So I'm not going to. You can try it out if you want to see what it prints out. It's not particularly interesting. Right, you can reverse the ordering using minus R. Right, by default it lists it in alphabetic order. Right, S is the size. T is the modification time. So that's the time at which the file was last changed. Right? So if you want to list the files in the order in which they were modified, you can use minus T. Right? So ls minus T. Notice that the output is different than just plain ls. Right? ls lists things out in alphabetic order. Right? Minus T lists them out in order of their modification time. Right? Now you might want to say, well, what was the actual modification time? Right? That's what L is for. Right, that's a little l, it's not a 1. That's a 1, right, little l. Little l is long format. Right, so long format produces more information about all the files, right? If you're in Windows, this is like asking for the detailed view of the files. So over here, right, file name, that is the modification time. Right, so it looks like I last touched io.ipynb in September. That's the file size. Right? These two things here are, so that's the owner. That's something called the group. Never mind what that is right now. The 1 is confusing. That's the number of hard links. Again, not so important for our purposes. And over here are what are called the file permissions. And we'll learn more about those in a later lecture. Right? And so you can get more detailed information using minus L. The problem with minus L is that the output of minus L is not described anywhere. So there's no standard output for minus L. Right? You normally get something that looks like this. If you're on a Mac, it probably looks different. Right? If you're on a different shell, it probably looks different. Right? Or in a different, or if you're in a different version of Linux, it may not give you this output. Right? It looks something like this. It may not exactly be this. Right? Okay, so many commands will accept the help option. Right? So minus minus help will display some help information for the command. Most, but not all. Right? So ls minus, so this is yet another way to get help for a command. Right? And so notice that it can be, the documentation of the command can be quite long. Right? So that's another way to get help. It doesn't work for all commands. Right? It depends on whether the command was written to support that option. For the shell built-in commands, you can either use the help command itself, right? Which is, you can use the help command itself. You can use the command called man and ask for the built-in commands, right? Or you can try the minus minus help option and see if that works. Okay, so what is this thing called man, right? So man is the program that displays a manual for a command, right? The manual is a reference manual. It's not a tutorial. So for the purposes of most people new to Bash, it's not super useful, right? It simply displays the information about the command. It doesn't actually tell you how to use it or give you examples on how to use it, right? So if you're looking for examples on how to use a command, you're best looking it up on the internet, right? If you get used to using a command and you need to know something extra about the command, or you've forgotten how to use something about the command, that's when man is useful. Right? So when you type in man, ls, man runs a different program called less, and it displays the contents of the manual page using less. Right? So man ls, give me the man page for ls, right? And you see something like this. Right? The man page formats are not standardized either. Right? So different commands, the man pages will look different for them. But usually, at the top, you'll see the name of the command, and you'll get a little description of what it does. Right? ls lists the directory contents. Right? Synopsis will tell you in brief how to use the command. Anything inside square brackets is optional. Right? ... means 0 or more. Right? So 0 or more options. right? Followed by 0 or more file names, right? If you pass in a file name, it lists information about that file. Right? All the options that are documented will show up here. There are undocumented options. Right? Now, if you want to scroll through the man page, right, man uses a program called less. So if you know how to use less, you can use the shortcuts there. Right? So to move forward one page, you hit the space bar. Right? To move backwards one page, you press B. Right? If you want help on how to use man, you can press H right down here, right? And notice here it gives you information about how to navigate through the man page, right? Notice there's lots of ways to do this, right? So you can move forward one line at a time, many different ways, right? You can move forward one window at a time, many different ways, right? And so on and so on and so forth, right? Press enter for more or Q when done, so Q, right? And quit will exit. So the man pages for a lot of the commands are quite long, right? Notice there's many, 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 many options to ls, right? So if I wanted to, I could fail everybody in the course, right? Because I could just ask you about one of these options. I'm never going to do that, right? You never have to worry about memorizing all of this nonsense, right? So don't worry that I'm going to do that, right? But the man pages are very long, so navigating through these things can be tedious, right? And ls isn't even a particularly complicated command, right? When you do the C part of the course, you're going to be using a compiler called GCC, right? The man page for that is gigantic, right? The HTML manual for it is gigantic, right? And so navigating the man pages for that sort of thing is very tedious at best, right? But they do exist, right? They are useful, especially if you don't have an internet connection, you can't look it up on Google. Okay, so there's a synopsis, there's navigating the man pages, right? If you want to try an example, you can do something like man cowsay. Assuming it's installed on your computer, right? You don't have to install cowsay, right? So here's a perfect example of another man page where the formatting does not look the same as the one I just showed you, right? So whoever wrote the man page for cowsay did not format it in any particularly nice way, right? Here's the synopsis. Right? They show you the options, but nowhere is there a list of the options. Right? You actually have to read all of this stuff to figure out what each one of these options means. Right? So the formatting for the man page is not consistent. Right? But you can do things like you can change the way the cow's tongue appears. Right? You can change the type of animal that's used to display the cow. You can change the way the eye looks like on the cow, and a bunch of other things as well. Right? If you scroll through and actually read the man page, you can actually figure out how to do all of these things. Right? I'm not going to do it right now. Right? So that's just an example of using man. Right? All right, so when you are working in the terminal, right, what you're going to discover very quickly is that a lot of the commands that you're using, you'll often want to repeat a command of some kind. Right? If the command that you typed in was long, right, then there's a good chance that you don't remember exactly what the command looks like, right? Or you would like to run the command without having to type in the whole command again, right? And so your shell remembers the sequence of commands that you typed into it, right? So that's called the history of, right? So you actually have access to the history of commands that you've typed into your shell, right? The history is finite. So, and the size of the history depends on how you've got your shell set up. Right? So the history command lists the history of commands. Right? So if you type in history, right, it spits out this numbered list of commands, right? And it shows you the command corresponding to each number. Right? If you want to repeat a command, so suppose I would like to repeat command 2112, right? You can just type in !2112, right? And that reruns the command for you automatically, right? This particular example, not super useful, right? I can probably remember how to do that, right? But if you're typing in a long command, then this is very useful, right? Other super useful things about your shell, right? And so they behave the same in Mac and in Linux, right? the up and down arrows move automatically through the history, right? So if I want to repeat the previous command, I can just press the up arrow once, right? If you press it again, that tells you the command that you typed before it, right? And again, right? And again, and again, and again, for as long as the history file, for as many entries as there are in the history, right? If you press forward, it moves forward through the history, right? So ls minus d, so I'm going backwards, right? And I'm going forwards again, right? So that's super useful too, especially if you're doing lots of work on the command line, right? If you typed in a command a few commands ago, it's easier just to type in the up arrow, bash the up arrow a few times. And then finally, another useful thing is that your shell knows how to complete file names, right? So I've got a bunch of files here, right? Let's see, I've only got one file that starts with L, right? So if I'd like to do something with that file, so for example, I want to know the size of that file, right? I could type in ls minus s, right? And then I could type in linked stack, right? IPYNB, right? So I could do it that way, right? But a faster way to do it is to type in ls minus s, right? Type in the L, right? And now press tab, right? And it auto-completes, right? And so the auto-completion algorithm, right? Back up, right? So if there's only one file that starts with L, it automatically completes that file name, right? And now you get linked stack.ipynb, right? There's multiple files that begin with S. So if I type in S and press tab, it beeps, right? If I press tab again, it shows you all of the possible completions, right? And then comes back to ls minus s, right? So if I want scope, I can type in the C and then press tab again, and it auto-completes, right? If I wanted strings, right, I would type in st. Well, strings is unfortunate. I have to type in strings, right? Because there's two files that start with string, right? So to get strings uniquely, I have to type in strings and then IPYNB, right? This also works with commands, right? So if I want a command that starts with C, I can type in C and then press tab a couple of, come on. Oh, wait, sorry, C. Oh, sorry, it was trying to do something. Oh, yeah, here we go, right? So if I type in C and then tab, it says, it tries to list all of the commands that start with C, right? It also took a little while on my computer. So there's 312 of them. So it asks you, do you really want to see all of these? And I say, yes, it does all this, right? So it can also auto-complete commands. Right, so the auto-completion feature is nice. You'll want to use it, especially when you're dealing with file names. It saves you a lot of typing. So there's tab completion. There are the man page. There's information about the man pages. And now we're into the wildcard stuff. Right, so I already showed you one wildcard up here. Right, so a lot of the things you're going to be doing is you're going to be operating on files in this course. Right? Depending on the problem you're trying to solve, there might be many files that you have to process, right? So for example, if I download everybody's assignment for this course, right, there's going to be something like 100 and I don't know, however many there are of you in this course, right? There will be that many files that I have to download from OnQ, right? So if you want to, often when you're working with large numbers of files, right, you want to work with groups of files. I might want all the students whose names start with A, right? Or I might want all the students whose names start with TH or something like that, right? If you do a lot of photography, often the files are named with the date, right? So you might want all your files from 2024, from some date in 2024, right? And so you might be looking for the directories that start with 2024, 01, 04, or something like that, right? So there's ways to specify groups of files, right? And that's called wildcard matching, right? So to match groups of files, there's a small number of symbols that you can use to create a pattern to match the names of those files, right? So I showed you star already. Right? Star matches any number of characters, right, including 0. right? So S star matches all the file names whose name begin with S, right? Question mark matches any single character, right? So S question mark would match all the files that start with S, having a file name of length 2, right? So SA, SB, S1, et cetera, et cetera, et cetera. Right? If you use square brackets and then put some characters inside the square bracket, that will match any one of those characters. Right? Square brackets, and this time exclamation mark followed by some characters, that will match any single character that's not inside the square brackets. Right? And then this funny syntax here will match anything belonging to a character class called CL with whatever name that happens to be. I'll show you that in just a second. Right? Okay, so if you want to list all the files in your directory, you could type in ls space star. Right? Star matches all of the file names having any sequence of characters. Right? A star matches all the files starting with an A. Right? It's very common that you want to list all of the files of a particular kind, right? So maybe all of your PDF files, or all of your PNG files, or all of your text files, right? So star.txt matches all files that start with anything, ends with .txt. Right? A star.txt, all of the files that start with A, end with .txt. Right? They can have anything after the A and before the period. Right? So star matches any number of characters. Right? Question mark matches any single character. Right? So question mark is any 3-character file name. Right? A, B, C, X, Y, Z. Right? If you have a question mark as part of a sequence of characters, right, then you match each one of the characters, and the question mark matches any single character. Right? So that's any 3-character file name starting with X, ending with Z. Right? This does not match XZ. Right? It has to match a single character. Here's an example of a character class. Right? So inside square brackets, I've got little y, big Y, 1 and 2. Right? So that matches any file name that starts with X, ends with Z, and has any one of these characters in between. Right? So XYZ, X big YZ, X1Z, or X2Z. Right? When you create a character class, you're allowed to create a range of characters. Right? So little a hyphen Z means any of the characters A through Z, right? In lowercase, right? Case matters. Right? So this matches any file name starts with an X, ends with a Z, and has a lowercase letter in between. Right? The ranges are funny, the way that Bash defines them. So it's not immediately obvious how they work. So you should generally stick with things that look like ranges that look sensible. Right? So A through Z looks sensible. Right? A through M would give you all of the letters, would match any of the characters A through M. Right? Also looks sensible. If you did something like Z through A, it's not clear what it's going to match. Right? So be careful when you're defining the ranges. 0 through 9 is any digit, right? Any single digit, right? And that one right there, right? Character class followed by a character class followed by .pdf, right? So that's any file name that ends in .pdf and has 2 digits as part of its name starts with 2 digits. Right? Finally, the character classes. So these things here are called the POSIX character classes. So these are predefined classes of characters corresponding to commonly occurring groups of characters. Right? So ALNUM is the alphanumeric characters, right? So all of the letters and numbers. So that's square bracket, colon, ALNUM, colon, square bracket. Right? Now, all of this, including the square brackets, has to go into another set of square brackets, which is slightly confusing, but that's the way it works. Right? So anything that's a number or a letter, anything that's a letter, right? Any single digit, any lowercase letter, any uppercase letter. There's a bunch of others as well, right? So there's ones for the symbols, right? So the non-alphabetic and non-numeric characters, and a bunch of other character classes as well, right? So for example, right? And you can use these with star, question mark, and exclamation mark as well, right? So square brackets, and then a character class inside, including the square brackets, right? Followed by a star, right? Upper is any uppercase letter, right? Star means anything. So this matches a file that starts with an uppercase letter, right? Followed by anything, right? Not upper, followed by anything, right? So this is any file that does not start with A through Z, right? Followed by any sequence of characters, right? X and then a digit is any file starting with X ending with a single digit, right? So any two-letter name starting with X followed by a digit. Oh, right? And so if you want to see these in action, right? What do we have in this directory? So I want to list all of the notebook files. Those are all the files that end in .ipynb. So ls star .ipynb, right? And there are all your notebook files, right? I'd like all the notebook files that start with S, right? So ls star .ipynb, right? Starts with S and has the has the Jupyter Notebook extension, right? And there they are. Right? I'd like to, is there anything here that starts, oh, there's only two that have uppercase letters in them, right? So if I want to list all the files that have an uppercase letter in them, ls star :upper star, right? So starts with anything, has an uppercase letter, right? Ends with anything, right? And so that gives you the two files that have an uppercase letter in them. Right? If you want to find the files that have a hyphen, an underscore in them, right? ls star _ star, right? And that lists all of the files that have at least one underscore in them. There's no way to restrict the pattern match to say, I want to find all the files that have exactly one underscore in them, right? There's no way to do that. So there's no notion of counting things when you do the pattern match, right? The best you can do is is to use the question mark to match a word of a name of a certain size, right? But you can't limit the number of hyphens, for example, right? Anything that doesn't contain a hyphen, right? So ls star, character class, no hyphen, no underscore, star, right? So that lists all of the files that don't have, so this is a tricky one, right? It lists all of the files that do not have an underscore in it, right? So it lists that, right? It lists, not ls star, I'm being a dummy. This doesn't do anything, I'm sorry. So this is an example of what not to do, right? There's no way for you to actually run this, to match the files that don't have an underscore in them, right? Why? Because the star matches anything, right? So, so that will always match, right? That will always match something, right? So anything whose name is not all underscores, this will always match, right? So all of these match. So that's something that you can't. That's another example of something you can't do. Right. All right. Any questions about the contents of today's material? Yes.
So if you type ls
Yep.
and then type a directory, it'll open that directory. How do you differentiate that from if you're just trying to perform a search?
So what do you mean by search?
Like if you do ls and then like the name of a folder, it'll
Yep.
list everything in that folder.
That's right.
But if you do ls and then like t asterisk, I'm assuming it'll list everything that starts with t.
Yep.
So how do you differentiate the two?
What do you mean? How do you? So here, ls. Okay, hang on. ls s star, right? So that matches all the files that start with S, right? Now what you have to remember is that the shell treats this as though it expands this, right? It does that, right? So when it expands to the file names. That's a directory name, right? The rest of the file names, right? And then it treats each one of these in turn, right? So because that's a directory name, it lists the contents of that directory, right? So that's why you get the output. That's why in the output it lists the contents of src, right? If you don't want that to happen, right? So in other words, you just want to know what are the names of the files that start with S, right? That's what the -d option is for. And if you're asking, how do I exclude the directory from appearing, there is no way to do that with ls, right? So there's no way to restrict, show me just the files, don't show me the directories, The best you can do is turn off the listing of the directory itself. Right, you have to use a different command if you want to list just the files. Good question. All right, anything else? We're done otherwise. All right, so I'll see you again next week.